Hi, welcome back to CMG-MathSpace. As stated earlier in our mission, our goal is to not only make you be able to solve math, but for you to enjoy and know why these operations or calculations are done. The concept is very important. For this reason, we did a conceptual video on the properties of set operations. In this episode, we are going to tackle the first one called commutative properties or property. We have three of them. We have commutative, we have associative, and then the distributive. Right. So in this episode, we are tackling commutative property. Now, before you actually watch this video, I would recommend that you watch the recent video on the concept of properties of set operations. Now, without further ado, let's see what commutative property states. Now, if you recall from that video, we said that commutative property says that it doesn't matter which set comes first, the result is the same. What do you mean by this? Now, in math, when we talk about these properties, commutative, associative, or distributive, we are just combining sets or operands with operators. And at the end of the results or the calculation, we should get the same answers or the same answer. Right? So when you take the left side of the operation of the operator, that's the equal to sign. If you solve it separately, and then solve the other one on the right separately, at the end of the day, you should get the same results. That is the main idea behind properties of operations. Right. So let's see what it means. If you check here, this is the question that we are going to do. We are going to do mathematical calculations, right, to prove these properties. So this is it. I've actually written them down in the exercise book, right? So just watch this carefully. I'm using AKI-OLA Core Math Edition 5. So we can check this and then we do that together. So let's go back into the book. So you can see here, right? That's part 14, right? Where we see this. So you can see here that this is a property, at least, or the formula I should call it. A intersection B is equal to B intersection A, or A union B is equal to B union A. So what does this mean? It means that the order or the order of arrangement of these sets doesn't matter, and they actually deal with two operands or two numbers or two alphabets or two variables. That is it. So A intersection B, if you go to the other side, when you reverse the order, B intersection A. If you solve this separately and solve this separately, we should get the same answer. That's what it means. The same thing is applicable to A union B is equal to B union A. So we are going to prove this in a calculation. For instance, we have been given set A, 2, 3, 4, and then set B, 1, 3, 5, 7. Right, now the first question is what? To find the intersection of A and B, and that is 3. Looking at these two, that's 3. The same thing for B intersection A, I think here should be A. Sorry, A intersection B intersection A, right, is 3. So what does this thing tell us? During this A intersection B intersection A, the same results, 3, 3. It's as simple as that. Now let's go the other way around. A union B. The first operator was intersection. Now it's union. So A union B, we have that means you are joining all the thing for the union. We are joining all the sets, the elements. You should remember this. Like I said, we are building up the blocks. So if you have not watched the series from episode 1, don't worry yourself watching this. You'll get confused. It's a building blocks that we are doing, right? So A union B, we are joining the element of A and B. That is it, 1, 2, 3, 4, 5. Still considering the set here. That's what it means. Now, B union A, we are just reversing the order. First, we started with A union B. Now we are going B union A. And we can see that the same result is here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The same thing. Be watching this. Take your time. Now, come again and see. A union B, A intersection B. Right? We are proving that A intersection B is equal to B intersection A because that was 3. We got it here. Now A union B is equal to B union A. It's the same thing. We got this 1, 2, 3, 4, 5. Right. So what it tells us is that intersection, that's intersection N, right? And union U of sets are commutative. It's as simple as that. It's as ABC. So we are doing the calculation, right? So I did this because of time. I didn't want to make the video very lengthy. I did the calculation. But if you pause this and do it yourself, you would understand or realize that it's the same result. A, B, you do the intersection, you do the union, and then we prove that this and that are the same. So the operations here on commutative, we are looking at union and intersection. That's all. We are not looking at any other set, right? So intersection and union. If you want to do normal calculations in math, we have addition and subtraction. It's the same thing here. For instance, 1 plus 2 is equal to what? 2 plus 1. You see that we just changed the 1 appeared first, 2 came later. Now 2 and then 1. The same thing is here. So this is what we mean. So 1 plus 2 is equal to 2 plus 1. They say if you solve this separately on the left side, it's 3. If you solve these two on the right side, it's 3. So that is it. The same thing is applicable to what? Multiplication. 1 times 2 is equal to 2 times 1. This is 2. This is also 2. It's as simple as that. Right. So this is the main idea when it comes to commutative properties. Right. It's saying that the order doesn't matter which one comes first. At the end of the results or the calculation, we have the same solution. So thank you very much for watching. Still on Operation 1K followers to start live. We will see you on that side. Bye for now.